नमस्कार दोस्तों, मैं अभिजीत और आप देख रहे हैं एबी स्टडी सर्कल। वीडियो में आगे बढ़ने से पहले अगर अभी तक आपने इस चैनल को सब्सक्राइब नहीं किया है तो इस चैनल को जरूर सब्सक्राइब कर लें और बेल आइकन को भी जरूर दबा दें, क्योंकि जब भी नया कोई वीडियो आएगा आपको नोटिफिकेशन मिल जाएगा।
Let's dive in. In this video, we will discuss about availability, and this availability is nothing but the maximum work that is obtained in a process. Okay, so availability, availability is nothing but the maximum work obtained in a process. When we can have that maximum work obtained, when the system is in equilibrium with your surrounding. Right, so that means your availability is the maximum work which is obtained in a process. Okay, so let's have this, say a system is at state 1, and the system, say it has some property P1 and T1 or V1, right, and this uh, system is interacting with the surrounding, which is, the system is at state A and it's interacting with the surrounding, say it is surrounding which is having the property P0, T0, right, or V0. Okay, so the maximum work that can be obtained with this system at state A1, when it is in equilibrium with this surrounding, we will get the maximum work W max, say it's denoted by phi 1, right. Now the system moves to another state 2. Okay, say it's having a property P2, T2 and V2. Now again, when it comes in equilibrium with the surrounding, it will have a maximum work W max as phi 2. Okay, now the maximum work, right, between 1 and 2, right, these are the states, is equal to phi 1 minus phi 2, and this is known as change in availability, right. This is known as change in availability, and this is what the maximum work which will be getting phi 1 minus phi 2, right. Okay, so this is what an availability is. The availability is nothing but the maximum work that is obtained in a process when the system comes in equilibrium with the surrounding. Okay, so let's move to find out, as it says that when the system comes in uh, equilibrium with the surrounding, let's have the case for a closed system, and let's try to find out what will be the availability of a closed system. So let's write heading for it, that is availability for a closed system. Okay, so we have this. Now suppose there is a system, say this is the system. Okay, I am writing it as system. Okay, this system is, say, giving some heat, that energy, right, Q. So for system, this Q will be positive, no, not positive, it will be negative, right, as per the sign convention is, it will be minus. For system it will be minus because it is rejecting this heat to the surrounding. See, it is surrounding, here we have surrounding, where we have surrounding, this is the whole surrounding thing. I denoted with this small space, so but it is the external to the system is all surrounding. And for surrounding, this heat which is rejected by the system Q will be positive. Why positive? Because it will absorb that heat, right. Now if the system is getting some heat Q, for system it will be positive because it is absorbing that heat, and for surrounding, as it is rejecting that heat to the system, it will be minus Q surrounding. Okay, now we have done this. Now again, for reversibility, ds universe is equal to 0. We have seen that in our previous video where we have talked about the principle of increase of entropy, and we have seen this thing. If you want to watch this again, how it happened, you can just click on my I button here so that you can watch that video. Okay, moving ahead, this universe is nothing but ds system plus ds surrounding. Okay, now for ds system it is minus ds surrounding. So when we apply our, as it is a reversible case, we can write directly as minus d cut q for the, as it is surrounding, by, for surrounding the temperature is T0, so we have this thing. But as it is minus d cut q surrounding, that means for system it will be positive. So I can write it as d cut q for system by T0, and from here we can find that d cut q for the system is T0 ds system. Okay, so we will apply this in a later bit of the video. Okay, now sorry, and now moving ahead, right, so moving ahead, we have for closed system undergoing a process, right, d cut q system is equal to du for the system plus d cut w for the system. So d cut w for the system, when it we are taking, when it interacting with the surrounding, right? So d cut q system minus du system. Okay, so d cut system we have just already got it as t0 ds of the system minus du of the system. See, the system, this, that means the system is going from state 1 to state 2. That means T0, it will be S2 minus S1, as it is a property. Entropy is a property, and internal energy again it is a property. So we have U2 minus U1. Okay, so let's bring this minus sign inside this. You will have U1 minus U2, this one, and it will be, let's bring the minus sign outside. You will have T0 S1 minus S2. Okay, so we have this as the maximum work that can be obtained. This is the maximum work, maximum work. But as this is a closed system, as this is a closed system, as this is a closed system, and the work which we got have to use some part of it against the atmospheric pressure, as it is a closed system. So the maximum useful work, maximum useful work will be W max minus the work done against atmosphere. Okay, so it is U1 minus U2 minus T0 S1 minus S2 minus P0 V2 minus V1. Right, let's open it. It will be U1 minus U2 minus T0 S1 plus T0 S2 minus P0 V2 plus P0 V1. So taking the one terms one side, so U1 minus T0 S1 plus P0 V1 like this, minus U2 minus T0 S2 plus P0 V2. So from here you can see that it will be, it is phi 1, that is the maximum work which is obtained when the system was at state A and it comes in equilibrium with the surrounding. You get this one as phi 1 and minus phi 2, as this one is for the state 2 when it comes in equilibrium with the surrounding, and this is the change in availability, right? So from here we can generalize the availability function. The general availability function for closed system is phi, that is equal to u minus T0 S plus P0 V. So this is what you have the availability function for a closed system. So this was a case for the availability of a closed system. Now let's now find out the availability for a open system, right? Now let's see how the open system will be interacting with the surrounding and what will be the availability of that open system. That is the maximum work that can be obtained in a process. That means that open system, when it is going for a process, what will be the availability of that system which is in equilibrium with the surrounding. Okay, see, uh, let's assume kinetic and potential energy of the system is negligible, right? Is negligible. Now we have the steady flow energy equation with us, that is H. I will write it as H1, right, plus C1 square by 2 plus GZ1 plus QCV is equal to H2 plus C2 square by 2 plus GZ2 plus W, right? Now as I said that, let's assume that kinetic energy and potential energy are negligible. So let's cancel these out. So we have left with H1 plus QCV is equal to H2 plus W. This QCV is the heat that is been entering the control volume. That means I can write it as D cut Q for the system is equal to H2 plus W. Okay, so the W for when it is interacting with the surrounding, you can write it as H1 minus H2 plus D cut Q system, right? Okay, now as I mentioned earlier, the system D cut system, it is nothing but T0 del S of the system, right? So it will be nothing but H1 minus H2 plus T0, that is the flow process is from 1 to 2, right? Again, so you have S2 minus S1 and you have H1 minus H2 minus T0 S1 minus S2. I can write it like this, right? So it is the maximum work that can be obtained in a open system when it is in equilibrium with the surrounding. Now, as this is an open system case, that means the maximum useful work is this only, right? So it is W max and it is H1 minus H2 minus T0 S1 minus S2. Okay, from here I can say this as H1 minus H2. I am removing the brackets, right? T0 S1 plus T0 S2. So I will having this as H1 minus T0 S1. I'm taking the state 1 conditions one side, right, minus H2, right, it will be minus T0 S2. That means this, when the process is when the system is at state 1 and it's in equilibrium with the surrounding, you have this as the availability phi 1, and this is when the system is at state 2 and is in equilibrium with the surrounding, you have phi 2, and for a process you have this phi 1 minus phi 2, and it is the maximum work, and this is the change in availability, change in availability. Okay, now this I can write it, I can write the availability function, the availability function for open system as phi equal to H minus T0S, right? I can generalize this as H minus T0S, and this function has another name, and Keenan function. If you heard about Keenan function, that means it is nothing but it's the availability function for a open system, and it is equal to H minus T0S. So if you find this video useful, to like it, share with your friends, and if you have any doubt, write it in the comment box.